quadratic function. They want us to answer these questions. And because it's in the ax minus p squared plus q form, standard form or vertex form, this becomes really easy. First of all, direction of the opening. Do you think it opens up or opens down?
Opens up.
Opens up. And you can tell whether it opens up based on the a value. Positive opens up. Negative opens down. Since it's in vertex form, what is the vertex? 3 and 1. Right? Always opposite of what's in here. So what makes this 0 would be 3. And then exactly the same as what you see outside. The axis of symmetry is the dotted line that cuts your parabola in half. It's always an equation that is x equals. And which x coordinate does it go through? It goes through the x coordinate of your vertex. So if your vertex is 3, 1, the vertical line going through that would be x equals 3. So you always can get this from the x coordinate of your vertex. Vertical lines are always x equal lines, and since it's going through the x value of 3, it is x equals 3. The intercepts. This we're going to do some work for. We need to find x-intercepts, and we need to find y-intercepts. The y-intercept is easier. I'll do that one first. How do you find a y-intercept? Algebraically. How do we find a y-intercept? Plug in 0 for x. So if I plug in 0 for x, you have to do some math. The number one mistake here is people think it's just the last number. But if I plug in 0 for x, things don't go away completely. Now I've got order of operations. Negative 3 squared will be 9. 9 times a quarter will be 9 over 4 plus 1. Get a common denominator of 4 over 4. My y-intercept is 13 over 4. My x-intercepts, how do you find x-intercepts? 0 for 1. Okay.
But don't we have no x-intercept?
What's that?
When it's moved up and opens up, we don't have an x-intercept.
I love it. Okay. Now, if you had done part B first, you would already be able to say, and I'm really happy with this, that y is equal to 13 over 4, and that there are no x-intercepts. Does it make sense? If it's opening up, and your vertex is at 3, so you move over 3 and up 1, will it ever hit the x-axis? Oh, scary things.
Here you go. Oh, sorry, guys.
I thought it was going to be a zombie or something.
No, it's just me.
Awesome. If you tried to solve this, how do you solve quadratic equations? You have 3 methods from our last chapter. You could factor, quadratic formula, or solve by square rooting. This one's really nice for solving by square rooting because it's already squared. If I tried to solve this by square rooting, I'd move the 1 over. I'd multiply by 4 to get the squared thing by itself. What's the problem when I try to square root?
You can square root a negative.
Right, we do plus or minus. This is not possible. So we would see that the answer doesn't come true if we did it algebraically as well. But the graphic way is so much
Yeah,
easier.
I mean, you can just look at the equation always when you have a positive a, so the parabola that opens up, and if you have a number bigger than 0 for the y-intercept, you don't have a x-intercept.
Absolutely. Domain and range. Domain for a parabola is easy. It's always everything. But your range depends on your vertex. And our vertex, it's opening up, so the y values have to be bigger than or equal to 1. Now, me personally, answering these 4 questions, I think is harder if you don't have the graph. If you take the time to quickly sketch the graph to begin with. 1, 2, 3, 1. Opening up. Technically, it would go over 1 up a quarter. Then over 1 up 3/4. I know this point here. Whoops, I labeled it wrong. That's 0, 13 over 4. That's my y-intercept. I know my vertex was at 3, 1. If I draw a picture of the graph early, domain and range are easier to see from the graph. Easy to see now that my y values have to be bigger than or equal to 1. Easy to see that there's no x-intercepts. Right? It's actually a fair bit of algebra just to get nowhere on the x-intercepts. So the graph can be very helpful that way. Okay, circle questions 6 and 8.